Hello. Today we'll be looking at this problem right here to help you get familiar with the equation that you saw on the slide, and to also get you familiar with predicting the sign of the change in entropy of the reaction. Alright, so for this problem, we're looking at the combustion of 1 mole of propane at 25 degrees Celsius. Now, when you see 25 degrees Celsius, that should automatically ring a bell that we're at standard conditions, but besides that, there's also another indicator right here, that tells you that you're at standard conditions. But enough of that. Referring back to the previous slide before this one, we're looking at how to predict the sign of the change in entropy of the reaction. And if you remember, um, we look at the shape of the reaction, and we also look at the change in moles of gas of the reaction. So let's start off with that. So off the top of my head, I don't know the shapes of any of these, but what I do know is the amount of moles. So we can see here that we have 1 mole of propane, and then we have 5 moles of oxygen gas. Here we have 3 moles of carbon dioxide, and we have 4 moles of water. But water is in liquid form, and right now we're only interested in the gases, so we're not going to take that into consideration. So on the left side, we can see that we have 6 moles of gas, and on the right side, we only have 3 moles of gas. So there's a decrease in the amount of moles of gas from the reactants to the products. So I predict that we're going to have a negative we're going to have a negative change in entropy of the reaction. Now let's see if my prediction is actually correct. So we will be using this equation right here. It's the change in entropy of the reaction is equivalent to the summation of the moles of times the change in entropy of the products minus the summation of the moles times the change entropy of the reactants. Sorry, it's not the change in entropy, it's just the entropy. But either way, so here we have our products and here we have our reactants, so we're just gonna flip them to each side, and our equation is gonna look like this. So the change in entropy of the reaction is going to be equal to we're going to put 3 moles of CO2, and then for the actual value of the entropy of for example CO2, that is a value that you can either find online or I'm going to use the one from the textbook. But yeah, so the entropy of CO2, it's going to be 213.7 joules per mole Kelvin, and this is going to be plus 4 moles of H2O times 69.940 joules per mole Kelvin. And all of this is going to be minus 1 mole times 269.9 joules per mole Kelvin. Let's see if I can squeeze it in here. And 5, just gonna put 5,205 joules per mole. Okay. Okay, cool. And all of that you put into a calculator, it should give you negative 374.0 joules per Kelvin. So as you can see, our prediction is correct. We do get a negative number. Um, I mean a negative change in the entropy of the reaction. So yeah, this is how you confirm um, your prediction by using this equation right here. So yes, thank you.